Take another problem based on kinematics. Problem based on kinematics. So I'm just writing the problem. The speed of a train increases at a constant rate alpha from 0 to v, and then remain constant for an interval, and finally decreases to 0 at a constant rate beta if d is the total distance traveled. Then prove that the total time is d by v plus v by 2, 1 plus alpha plus 1 by beta. So in this problem, the speed of the train increasing at a rate of constant rate alpha means alpha is nothing but the acceleration. Similarly, finally the speed of the train is decreases to 0 at a constant rate beta. Beta is nothing but a retardation. Total distance d is given, and we have to prove that the total time is d by v plus v by 2 bracket 1 by alpha plus 1 by beta. So now we will see how we can solve this problem. For solving this problem, just draw a diagram which represents velocity versus time. This is velocity, this is time. We have velocity. So now according to the problem, the speed of the train increasing at a constant rate from 0 to this value is v, and then remain constant for an interval, and finally decreases to 0 at a constant rate beta. So this one is the velocity v here, and the total distance, that is d. So here we know the acceleration, that is alpha. So alpha is nothing but change in velocity, that is v minus 0. And suppose for this interval we are having the time t1. So for this interval we are having the time t1. So here we are having alpha was to v minus 0 divided by t1. So this one is the time interval t1. Suppose this one is the time interval t2, and this one is the time interval t3. Similarly, we can also find the beta, that is nothing but v minus 0 by t3. So we are having alpha and beta. Beta we are calling it retardation. So directly we are mentioning it is retardation, so no need of a negative sign, because negative sign will tell it is acceleration of retardation. So alpha is v by t1, so t1 will be v by alpha. Similarly for beta, that is beta equals to v by t3, so t3 will be v by beta. So we are having t1, that is v by alpha, t3 equals to v by beta. Similarly, we know the area under velocity time graph will represent the distance. So distance traveled that is t. We can say the total distance traveled. That is d. It is nothing but area under velocity time graph. So see, this one I am giving the point name, that is suppose O, here A, B, C, D, and suppose this one is E. So here we are having area of triangle OAB plus area of rectangle ABCD plus area of triangle CDE. So area of triangle OAB is 1 by 2. This one is V and this one is T1. So we are having 1 by 2 V into T1 plus area of rectangle BACD is nothing but V into T2 plus area of triangle CDE is nothing but 1 by 2 V into T3, and this distance we know D. So from here we can write 2D by V equals to T1 plus twice T2 plus T3. So we are having the expression that is nothing but T1 plus twice T2 plus T3 equals to twice D by V. Writing the equation T1 plus twice T2 plus T3 equals to twice D by V, and we know T1 is V by alpha and T3 is nothing but V by beta, and this one equals to 2D by V. So twice T2 will be 2D by V minus V by alpha minus V by beta. So T2 will be D by V minus of 1 by 2. We have to take V common. So 1 by alpha plus 1 by beta. That is 1 by alpha plus 1 by. The total time T will be T1 plus T2 plus T3. So T equals to T1 we know V by alpha plus T2 means D by V minus V by 2 1 plus alpha is 1 plus beta plus T3 we know it is V by beta. So now we are having T equals to D by V, and if we see that V by alpha here, V upon twice alpha, similarly minus V upon twice beta plus V upon beta. So T equals to D by V plus V by 2 1 by alpha plus 1 by beta. So this one is the desired expression for T in terms of D, V, alpha and beta. So it's proved. Let's take another problem based on kinematics. I'm just writing the problem. A stone projected vertically upward from a point A passes a point B after 3 seconds if it returns if it returns to A after a further interval of interval of 4 seconds, and find number 1, the height of B above A, number 2, the velocity with which the stone passes the point midway between A and B. A and B. So this one is the desired problem. Here a stone projected vertically upward from point A, and it passes the point B after 3 seconds, and if it returns to A after a further interval of 4 seconds, then we have to determine the height of the B above A and the velocity with which the stone passes the point midway between A and B. Let's solve this problem. So I'm just drawing the points. So stone is projected from the point A. This one is suppose point B, and I am taking the highest point, that is suppose C, and this highest point distance is x meter, and I am plotting the point D, that is the midpoint of A and B. So now let's U is the initial velocity. So in the problem it is mentioned a stone is projected vertically upward from A and it passes a point B after 3 seconds and it returns to A after 4 seconds. So for a journey from A to C and C to B, it will take a total 3 plus 4, 7 seconds. So journey of stone from A to C and C to A will take 3 plus 4, 7 seconds, and displacement in this journey will be 0 because initial and final point is same. So it's a motion with uniform acceleration, means there is a motion under gravity and g is constant. So we can say that it's a motion with uniform acceleration. So we can apply the conditions based on motion with uniform acceleration. So let's apply the condition equation s equals to ut plus 1 by 2 at square. Here I am defining positive upward and downward directions negative. Total displacement is 0. U total time taken it is 7 seconds plus 1 by 2. G is acting in downward direction, so it's minus g according to our sign convention into 7 square. So we are having 7u minus 1 by 2. The acceleration due to gravity value is 9.81 into 49. So we are having u equals to 9.81 into 49 divided by 2 into 7. So it will come around 34.3 meter per second. So we calculate the velocity, that is 34.3 seconds. Now we have to talk about motion from A to B. and we know from A to B the time taken will be 3. It is mentioned in the problem. So time taken from A to B by stone will be 3 seconds. It's given. So we can easily find out the displacement. We can easily find out the uh, position of B with respect to A. So suppose the position of B with respect to A, this one is suppose S. So S, and it's a motion under gravity, that is motion with uniform acceleration. So we can apply S equals to ut plus 1 by 2 at square. So here we have to find out S. U we have already calculated, that is 34.3. It is in upward direction, so positive. Time is 3 plus 1 by 2. It's a motion under acceleration under gravity, so you have to take G, and it's in downward direction, negative. T is 3, so 3 square. S equals to 34.3 into 3 minus 9.81 by 2 into 9. So if we simplify it, it will be 102.9 minus 44.1. So we can get the things. It is nothing but 58.8 meter. So the height of B, or we can say that the height of B above A, that is 58.8 meter. Now we have to find out the velocity with which the stone will pass through a point between A and B. So I am again drawing the points here. It is A and B, and here it's a midpoint, that is T. And in previous part we have already found the AB value. It's nothing but 58.8 meter. So the AD distance will be 58.8 divided by 2. So it will come around 29.4 meters. So now in part 2 we are interested in the velocity with which the stone will pass the point D. So we are interested in the velocity at point D. So it's a motion with uniform acceleration, motion under gravity. So we can use any equation from the three equations based on motion with uniform acceleration. So I am using this equation, V square equals to U square plus twice AS. So here we know we have already calculated the value of U, that is initial velocity, 34.3 square plus 2. It's a motion under gravity, so that is G, and it is in downward, so minus, and the distance, it is 29.4, and it is going upward, so it's a positive. So now if we write it like V square equals to, so it's a 34.3 square is nothing but 1176.5 minus 2. The value of G is 9.81 into 29.4. We further simplify, so we will get 1176.5 minus this 2 into 9.81 into 29.4 will come around 576.83. So V square we will get 599.67. So V will be square root of 599.67 equals to 24.5 meters per second in upward direction. So the velocity with which the stone passed through a point D, or we can say that the midpoint of AB will be 24.5 meters per second. Now let's take another problem based on kinematics. Problem based on kinematics. Here I am writing the problem on turning a corner. A motorist rushing at 15 meters per second finds a child on the road 40 meters ahead. He instantly stops the engine and applies brake so that so as to stop the car within 5 meters of the child. Now calculate number 1 retardation, number 2 time required to stop the car. Time required to stop the car. So here in the problem it is given during turning a corner, a motorist initial velocity is 15 meter per second. He finds a child on the road that is 40 meter ahead of the car. He suddenly applied the brake so as to car stop within the 5 meter of the child. In that condition, we have to find out retardation. Retardation means negative acceleration we have to find out, and at the same time we have to find out the time required to stop the car. Problem. In the problem, initial velocity of the car that is denoted by u is given, and if the car is stopped then the final velocity will be 0, and in the problem it is mentioned the driver wants to stop the car within 5 meter of the child. So initially child is at a distance of 40 meter and he wants to stop the car within the 5 meter. So before stopping, the car will travel the distance of 40 minus 5, that is 35 meters. I am again repeating this thing here. Suppose A point there is a car, B point there is a children. So initially the child is there. So initially the distance is 40 meter and he wants to stop here at a point C. So CV distance is 5 meter. So if we apply the brake and at A, so vehicle will stop at C. So during that interval, it will travel a distance of 35 meter. So we know the S, we are having U and we are having V. So and it's a uniform retardation. The retardation in this problem is uniform, so we can say that it is motion with uniform acceleration. So we can apply the equation based on motion with uniform acceleration. So I am applying the equation which is based on motion with uniform acceleration. V square plus u square plus twice as. Here v is 0, u we are having 15, so that is 15 square plus 2 into a, we have to find out s, that is 35. So here we are having 225 plus 70 into a. So a will be negative 225 divided by 70, so it will come 3.21 meter per second square. So it is coming negative. So we can say that A is 3.21 meter per second square retardation. So we can easily find out this value. Now we have to find out time required to stop the car. So now we are interested in time t. So we have one more equation, that is v equals to u plus at. We know v is 0, the u we know, that is 15, plus a we are having the value minus 3.21 into t. So t will be 15 divided by 3.21 from 4.67 seconds. So the time required to stop the car will be 4.67 seconds.